Happy Friday. Since there are already kind of a big group here, well, not a big group, but a noticeable group, should we just start early rather than waiting? What do you guys think? I have, just for the fun of it, an attendance register. Someday I will plot attendance versus scores. That's already been done, though. That's just, people have already studied that. And it's not, the results are not very surprising. Before I start answering some questions, I just thought I would share some personal insights, let's say. I'm very surprised about this. I do look at the analytics on YouTube to see what the class is up to, or just to get an idea of what the class is up to. I can't tell exactly because it's anonymized. But this is the previous revision lecture, and I'm very surprised that nobody is looking at this. I'm very surprised about that. If I was a student in this class, I would be all over that revision lecture. And I would have watched it before I came today. And I'll give you a hint. Some of the test questions are asked by students from this lecture. So the students were bombarding me with questions for that lecture. It's almost 90 minutes long. And I even said out loud, oh, that would be a good test question. Like, I didn't think of all these interesting questions. Okay, I have a few amazing questions via email that we can look at before you guys start asking your awesome questions. One is, good evening, Bob. Just a quick question. I like the quick ones. Are there any solutions or model answers to any of the DataVis past papers or similar questions? I understand that the university has a policy of not releasing model answers, much to my dismay, but it would be great to get to grips with the correct format of our written answers. For example, question 1B of the 2017 past paper states, compare the three hierarchical visualizations or diagrams you identified and described in part A above. What are the relative strengths of each? It would be great to know the best way to go about answering a question like this. So the short answer is yes, there are past model answers publicly available, and the answer is not going to be too shocking to you, I think. But there is a playlist on the DataVis YouTube channel where I answer previous test questions like exactly like the ideal way, right? It's called Visualization and Related Questions and Answers. So if you look at that playlist, you will see students asking questions from previous exams and me giving the model perfect answer. Well, you know, an answer that would at least score a distinction. And one of the things I'm looking for is drawings and accurate, correct drawings. So that's a hint. So a lot of the questions will say, please provide an illustration or a drawing to support your answer. So I'm looking very closely at the drawings, very closely, because the drawings really tell me what you understand and what you don't understand. Better than natural language text. But your drawings will be annotated with natural language text as well, like this is the minimum value, this is the maximum value, like this is something, this is the y-axis, you know, and the x-axis is mapped to scalar value and things like that. So if I click on there, you'll see model answers of some previous test questions and so on. Some of them are a little bit more than what I would expect actually, but at least you get the idea there. So I hope that answers that question. I will save that one for later. Okay, so somebody at least watched, I can tell that this student at least watched the revision lecture hints video, the last one from lecture 17, lecture 17.3. Hi Bob, I have a silly question. In your exam preparation video, you mentioned that the InfoVis questions will be made more challenging to stop people skipping flow visualization. Does this mean that all three questions, InfoVis, VolVis, FlowVis, are to be answered this year, or does it remain answered 2 out of the 3 questions as it does in previous years? I almost don't want to answer this. It will remain to answer the best 2 out of 3. However, I have tried to revise the exam such that the people that skip the flow visualization material won't be as happy. I guess I'll just put it that way. I can see that a lot of people just say, oh, okay, 2 out of 3 skip FlowVis. I'm trying to juggle that kind of mindset this year. So I've raised the difficulty of the InfoVis, or I've tried to. Maybe I didn't succeed, but I've tried to. So when you see those questions, you might think, ah, I wish I had studied the FlowVis stuff too. Is it Kasia?
Yeah, volume Vis and FlowVis gonna be merged together, or it's gonna be still separate? If you don't mind asking the question.
Well, I won't answer that question directly, but what I will say is I gave a lecture, I gave a lecture and it talked about the organization of the module. And the module is organized in, and I say this in the lecture too, which is in the lecture on the YouTube channel. There are 4 components to the module, not just 3. So some people have this idea, oh, it must be InfoVis, it must be VolVis, and it must be FlowVis. That is not actually true. Does anybody know what the 4th component of the module is? Nobody has any ideas? Yes, exactly. There's an introduction. So there are maybe 3 lectures before we actually get to the InfoVis. So that's the 4 parts. So I have 4 areas I can choose from to make it more exciting. Does that help? But your suggestion is very good. I should mix and match. I should mix and match the things up so it's not purely InfoVis, purely VolVis, and so on. Yeah. Okay, here's another one. I was just wondering what your thoughts were on including categorical data in parallel coordinates. The use of coordinates imply that numerical data is required. However, treating these categories as discrete numerical data would make it possible for them to be included. I could see this working well if only a few categories were present, but then I think it would end up quite messy and difficult to understand as the number of categories increase. Would you say that it's bad practice to include categorical data, and should I instead use a different visualization technique? This question is inspired by question 1C on the 2016 PAST exam. There are 7 attributes to visualize, country being one of them. So I think it's absolutely fine to include categorical data in parallel coordinates. I would be very interested to hear Alfred Inselberg's answer to that question, who's the guy that made the parallel coordinates so popular. But I see it as perfectly fine. So in that question that the student is referring to, there are something like 6 6 countries to choose from, or 5 countries, and you can assign each one of those countries a position on one axis of a parallel coordinate, and it's absolutely fine, there's no problem. You can even just have 2 categories, like true, false, or yes and no, as 2 points on a parallel coordinate axis. I don't see it as any problem. So anywhere from 2 to, well, infinity in terms of the number of categories. Numbers in some ways are also categories because, well, you only have a finite number of pixels on the screen, right? So the line has to connect to one of those pixels, and there can't be more than 1,000 of them typically, so it's like having 1,000 categories in some ways. So, yeah, I hope that answers that question. This is a question I don't understand, so maybe somebody can help clarify this a little bit. Hi Bob, I've been working on past papers for CSC M37 and I have a question, hope you can help. What would you recommend as a method of information visualization with mixed text and numerical data? Is the person here who asked this? Conveniently not? No. I'm just going to ask for a little bit more clarification. I think what I would recommend does not only depend on what kind of data is involved, but also where the data comes from. So the data comes from somewhere, and what I would choose also depends on where the data comes from, who collected the data, and what questions they are trying to answer. But so this is confusing too, because mixed text could imply categorical data, like we just, the previous question just answered. If it's raw text data, for example, a paragraph from a report, there are techniques to visualize raw text data, and we don't actually go into that in this module, which is kind of a pity. And there are several text visualization techniques. Does anybody happen to know one? You've all seen one before, but you may not have realized it's a text visualization. The word cloud. Yes, a lot of people used it for assignment 1. That's right. So, yeah, it depends on what the task is in order for me to answer this question, really. It depends on the task. But for example, I can imagine using a mixture of scatter plots and special text visualization methods like word clouds or word trees or something, some variant like that. So it's fine to combine different visual designs together. And we had an amazing lecture on that topic too. Does anybody happen to remember what that's called? It's one of the least viewed lecture videos from the module. It's called Coordinated Multiple Views, where you can mix multiple visualization designs together, and they're linked and coordinated, and try to get the best of multiple worlds together. Okay, does anybody have any questions? I hope I can answer. If nobody has any questions, then we're finished. But I think... Okay, which one did you... the ranges. Yeah? How to set the minimum and maximum?
Yeah, because like I said,
yes.
You start from, let's say, 0 at the bottom. And
Yep.
It's quite clear you start from 0, but sometimes you have like 5.19. So what does that mean? Does that mean
That's a good question, and I'm going to answer it. I hope. I even brought markers. I'm going to use this amazing whiteboard for the first time today. Maybe, assuming the markers work. So this question, if I understand correctly, is how to choose the min-max ranges on parallel coordinates. Is that
Yes, but also
true?
how they're visualized, because I noticed in the book, for example, there were cylinders, you know, when we talk about cars. So you have one line, right? And at the bottom it says 2, and at the top it says 8. But the polylines never reach the very top. They only go somewhere below.
Yep.
And they never reach the very bottom. So what does that mean? Does that mean the highest value is 6? Or is it 8? You know?
So I guess I'm going to start off by drawing Cartesian coordinates. So these are Cartesian coordinates, that's the x-axis and that's the y-axis. This is sort of one way to draw Cartesian coordinates. And the origin is 0, 0. And the origin is kind of the minimum and maximum in this version of Cartesian coordinates. But if you talk to a mathematician, are there any mathematicians here? They will not really like this. A mathematician will much prefer this version of Cartesian coordinates, where the origin, or 0, 0, is at the center, like this. And your min and max, how you choose the min and max is, you just, as long as they're labeled, you have to make sure that your min and max include all the data. That's all. That's all. A mathematician will always choose something like this with the origin at the center. I'm still going to get to parallel coordinates. But it's okay if you choose something like this if all your data is positive. Right? This is positive x and positive y, negative x and negative y. So as long as you have all of your things included there, you just have a maximum value and you just say whatever it is. And then here it would be, here you do the same thing. Max 10 and then like minimum 10. As long as it's labeled, it's fine. And in the parallel coordinates view, I'll draw the two versions, so to speak. In the parallel coordinates view, the two versions would look, they just look like this. So you can't say much until you start plotting data. But I can tell you that Alfred Inselberg and mathematicians would always draw parallel coordinates like this with a 0 line down the middle. They would always do that. So 0 is always at the middle, and then the minimum is down here, like minimum could be minus 10, for example, and the max is 10. And in the sort of the layman version, you could have like your minimum as 0 here, and your maximum as 10 here. As long as it includes all the data. Now in that specific example with the cylinders, you had like 2 and 8. Right, for your test question, or a test question, you want to label every cylinder and you want to actually have min and max values there explicitly. 1 second. So you said none of the lines are pointing towards 2, and did you say some of them are pointing towards 8, right?
No, they were not.
Not in that one?
You at least labeled where that 8 is,
Yeah.
but in the book it's not, it's just above the line. So
Yeah.
when I was trying to get the data, I thought, what if I tried to recreate the data table? And I just couldn't because it didn't make sense,
That question implies a little bit that you know something about cars. So cars have cylinders, these internal combustion chambers, these are internal combustion engines with a number of cylinders, and the number of cylinders is always 1, 2, 4, 6, or 8, like for basically
I
almost
tried to go
all.
that way, I tried to go that way, but it
Yeah.
doesn't make sense, like the gaps between, let's say, I thought, okay, let's mention this is 8, and this is 6, and the other gap, no? The other
Okay.
gap implies it would be something.
Probably you don't have to, you know, this, in this case, this would be 6, this would be 4, and this would be, oh, 2's down here. Wait a second, I would try to divide it evenly. So something like 4 is halfway, something like that, and 6, something like that. That's not very good. But as long as, if you want to avoid any problems, like, this would be better to. I brought another marker because just in case, this is how well prepared I am today. 2, 0. So that's a little bit nicer. But the sort of the reasoning was that you implicitly knew this, that you knew an engine has 0, 2, 4, 6, or 8 cylinders usually, and that you'd be able to infer any other values based on that knowledge. No?
Like I said, when I tried to, because the gaps, like, that's...
The gaps don't match up very well, is what you're saying?
Yeah, that was my reason as well. If it's nicely, you know, done like you just
Yeah.
did, then yes, it's quite easy to say, oh, okay, yeah, 2 is here and then 4 is... No, they were not equal, so I thought, okay, so this implies this is 5 or 7, you know, something like that. But
Yeah.
I just thought, you know what, so for exam, should we just do 0 at the bottom? And, you know, write the 0 and then...
0 is a very good minimum by default, yes. But you want to, if you have negative values, you need to include those too. So your minimum should be, you know, your parallel coordinates probably look more like this.
So what if we have, let's say, 2 dimensions and one has values from positive to negative? I can do positive to negative, but the other one I can just do positive to 0?
No, I would choose this design. So you might have a big cluster of all positive values here, and some down here, and nothing here. But I would choose a consistent, you know, something consistent. Yeah. Rodri?
Can you, do you mind if you use, I don't know what the right term is, the like squiggly line to represent that there's nothing happening between these intervals?
I don't think you're going to find a test question that requires that idea.
In general case, what would you say?
I wouldn't add like a squiggly, noisy line that
Do you know
tries.
what I'm on about? Like on the axis where you do like up one triangle, down one triangle to say that there's nothing happening from the interval 0 to where you start. So like your axis is like this, you have this symbol so that you're just saying you're skipping.
I wouldn't do that. No, I think you'll confuse the world. Where did you get that idea from? Where did you see that?
I mean, that's a pretty normal notation if you're drawing graphs in math. When you want to, if you have like positive and negative values but nothing around 0, why draw a graph that's like 3 meters long or whatever? Just
I see. Yep. Okay.
I mean,
Yeah.
excuse the perception, but
Yeah. I wouldn't recommend that for the test. Any other questions?
Are there any pros of Venn diagram?
Pros of Venn diagrams, that's a good one. Well, the Venn diagrams, it depends on, everything is relative. They're better than something, right? So I would say that they're better than tree diagrams in terms of you could represent more data in a hierarchical Venn diagram than a tree diagram. If you think especially of a bubble chart style. Another advantage of Venn diagrams is they convey is type of relationships. a little bit more intuitively than other hierarchical. So they also, well, but traditionally they're really used to represent, like, has something else in common, like has commonality where the bubbles actually overlap. But yeah, so Venn diagrams are not usually chosen actually for hierarchical data. But the reason they're in there is because they do provide an example. But tree maps and Venn diagrams are kind of very similar in some ways. Because if you take a Venn diagram and you just change all the circles into squares, you don't get a tree map automatically, but you get something very tree map-ish all of a sudden. But in Venn diagrams, you could have overlapping circles, not in a proper hierarchical visualization though. And in tree maps, you don't generally have like two square nodes or rectangular nodes at the same level in the hierarchy overlapping. You would not find that. But I think that would be a fun idea, but you don't generally see that. Does that help answer that question? You could say that another advantage of Venn diagrams is that everybody has seen them before. That doesn't mean that everybody understands them, but I think, well, a lot of people have seen Venn diagrams before. A lot. I don't know how many, but a lot. So they're still more common than tree maps. Any other? I'm waiting for a question where I just go, oh, I don't know.
In the revision document, you have a list of terms and such. One of them, glyph design. So for glyph design specifically, outside of have a picture, say, stickman or something, having a shape around it, having colour, and that represents at least three sort of dimensionalities. What else can you use to represent different dimensions in a glyph? Makes arrows?
We had an amazing lecture on glyphs. So, does anybody happen to remember one of those glyphs that had 10 dimensions? The rugby ones, yeah. So that is a lot of information in one glyph, but that is an example of a glyph. I can use 10. It's complicated, but that's one example. Does that answer your question? Are you?
So, yeah.
I can tell you that there's another amazing video that designs glyphs from scratch here. Glyph design for flow visualization. So there you can see me like drawing glyphs from start to finish that have up to like 5 or 6 different attributes mapped to them. Step by step how I derive all the different attributes, and I make a nice little table. It's called a swatch chart. A swatch chart is a glyph, a table of glyphs, and it modifies each part of the glyph, and it shows you what it looks like at the minimum value to the maximum value for every different attribute on the glyph. Like for the Chernoff faces, it would start with like maybe a mouth, the mouth that's like very narrow, to when the mouth is very wide. Like min mouth, maximum mouth, like min eyes, maximum eyes value for every different piece of the face. Does that help? I mean, a Chernoff face is another possibility. They're not very exciting. I would say the Floviz glyph is a real example. Well, I mean, the rugby example is real too. But the Floviz one is very common and practical. Yeah. Carlo?
I have a question about labeling tree maps.
Mm-hmm.
Because is what conventionally you follow up to label? Because you can end up with many labels in the same space. once you do the hierarchies?
Yes, that is a good question, actually. And the tree maps, there are the kind of the two styles of tree maps too. One has no explicit child-parent borders, and one does. Oh, did I not bring an eraser? Anybody see an eraser hiding here? Or something similar? I might have something. If anybody just sees an eraser hanging around that I don't see, let me know. I forgot to bring an eraser. I suppose it's not the end of the world. It would be a good spot for an eraser. So for the labels of a tree map, I was pretty lazy when I was doing the tree map construction example in lecture. You can rewatch that where I do place the labels. But I'll do it again. And I would say if I was answering a tree map question, like really a good thing to do would be to use arrows to just make sure that you have your labels. So A is at the top. Now for the root, I always just put the label there. And then it gets subdivided into two, right? So B and C. This is not necessarily the world's best way to do it, but it's one way to do it. D and E. So D and E. You see there's a space here.
So
A blank
like
space.
Imaginary lines, basically.
In this example, yeah. You could, if I was writing a test and I just wanted to be really extra cautious and make sure that there were no misunderstandings, I would put something like root, level 1, something like this, level 2, and D can be subdivided, F, G, D, A, B, C, D, F, G, something like that. Or, well, you don't have to put this here. G, and then I would say something like level 3, just to be on the safe side on the exam. This I highly encourage you to put some annotations on whatever you draw in the exam, whatever you draw.
Would it be better to just leave margins so when you label something that's clear, it's not that?
Yeah, that's definitely another possibility, and probably it's a better one actually. So A, and then draw explicit rectangles. That's another possibility. So B and C. And then D and E. So in this case it would be like this. D and E. So yeah, probably you're right. You'd probably be better this way. F and G. F and G. So that you wouldn't have to annotate anything there. It would be very clear, very obvious. And this gets back to that Venn diagram thing. If all of a sudden these were circles, it would be just like a Venn diagram. Good question.
the same paper, basically.
Mhm.
At one point, there's an example of pseudocode, and there's a question about input and output of the algorithm.
Mhm.
Is it just basically just saying what the annotation actually means? So node would be the root node, orientation would be the way you cut the tree map, origin, the point from where you start drawing the tree map, something like that, just describing as if
That's
we were
right.
documenting the piece of code.
Exactly, yes, yes. And the input there is a data hierarchy or a hierarchical data set. And the output, what I was thinking at that time was the output is a set of rectangles. Yeah,
So
or a tree map.
Oh, okay, because I looked at the tree map, so now you
Yeah.
rather the set of rectangles will make the tree map. Okay.
Any other exciting questions?
I was also reading about tree maps and they mentioned neighborhood preservation, but I don't actually understand what that means.
Neighborhood preservation.
Yeah, I don't remember if they have it or don't have it, but
That is something, I don't think we didn't talk about that in lecture. So, well, actually, there was one person that talked about that in lecture. Does anybody know who that was? It wasn't me. Chow Tong. Was anybody here for Chow Tong's presentation? Chow Tong came in here and gave a presentation about cartographic tree maps. Nobody was here for that. He talked about adjacency preservation. And that's not going to be on the test. But what that refers to is, imagine you have this country, like this amazing country that looks like that. And you wanted to represent the states in a map, on a tree map. You know, somehow, right? Everybody's favorite state is Maine, right? It's up there. And then there's Florida. Like, the question is that possible? Like, can you preserve neighborhood or neighbor relationships from the geospatial map on the tree map? That's what that's referring to. And anybody know the answer?
Yeah.
The answer is no.
True.
Yeah.
What about you can map maps into a graph structure and then
You can.
preserve the neighbors.
You can do that, yes.
What can you do with a tree map?
Well, the tree map is very, so here's the reason. The basic answer is you can't do it with the traditional tree map because the traditional tree map doesn't allow gaps. That's the short answer. I'll try to illustrate that. Like, imagine you have this state. This is a good one. You know, you have a square in your tree map and it happens to be a state that's surrounded by lots of other states. There's kind of a limit. There's kind of a limit to what you can do there in terms of your neighbors. You could say, oh, I have 5 western neighbors. I will just make them all very long and thin. But look what happens. Look what happens. There's a long, thin one stuck between 2 other long, thin ones. What if they have like 5 southern neighbors? It starts to, you can do it only if you introduce gaps. You can approximate, you can do some tricks, approximation tricks if you introduce gaps.
What if you don't use
Rectangles.
rectangles? I'm pretty sure trying.
If you use arbitrary shapes, you could do it. Then it's just like this.
Because I'm thinking the full color theorem, which
Yep.
is kind of similar.
Yes. If you want to work on this problem, this is an open research problem, and Chow and I have worked on this a little bit. That's what cartographic tree maps is all about. That's exactly what the problem is. It's, can we get the best of both worlds? Can we get something that looks like a tree map and a cartogram? Like, can we combine these two? That is his PhD thesis, essentially. So yeah, it's a good research topic, and there's a lot of great unsolved problems hiding in there, and yeah, it's a fun topic, really fun topic. Like one of the unanswered questions is like, how do you represent distributions on a cartogram? I've never seen anybody attempt that before. Yeah. Any other questions? That won't be on the test, that one. I guess I can see this class really likes tree maps. What's your question?
Can multivariate data can be turned off?
Yes, so there's no reason why multivariate data and hierarchical data cannot be combined. Like, you can think of a family tree. A family tree is hierarchical, patriarchy. But it is also multivariate. It has gender. You could include like age, like place of birth, whatever you want to collect, whatever attributes about people you want to collect, how tall they were, something. So there's no reason why you can't have hierarchical and multivariate. Yeah. Other questions? Good, good.
You know, I was reading about volume visualization, and I think I absolutely misunderstand what interpolation means. So, for example, you say voxels and cells, and you say voxels not always interpolated, cells are always. I don't actually understand.
Yeah, that slide is hard to is a little bit weird and a little bit hard to understand. The idea there is, for a cell, all of your data is stored at the corners, and usually you want a data value that's not at a corner. For example, here along the edge. And in order to get this value, you need to interpolate between the two values along the corner. Are you with me on that or not?
Well, what do you mean by that? So you're working on data, what do you mean when you say interpolate? What do you do?
Interpolation means deriving a data value where it doesn't already exist in space. So what probably might help is just to redraw this. And draw it without any edges. So if we have 4 data samples, so these are 4 known data samples, and we want to know what is the value of the data here, how do we find out? Like, how can we derive a data value here where it doesn't exist? There's nothing here, it's just empty space. But yet it represents, this space is supposed to represent something in nature, like a person's skull, or a river flowing, or a body of air. So these 4 sample points are trying to represent something in nature that's continuous, that doesn't have gaps between the data samples. So in order to represent that, we can take data samples, like with a CT scanner or an MRI scanner or some sort of weather station. We collect the data samples, put them on a spatial grid, and then to fill in the gaps, we need to use interpolation to get a smooth and continuous representation of whatever phenomenon it is we're looking at. Did I lose you?
It's a bit clear, but I only you know when it doesn't like, because usually when you understand something, it creates a picture in your head. And
Yep, I'll try a little bit more. I'll try one more time and see if this I'll try an example. Which country are you from again? The Ukraine?
Lithuania.
Lithuania. I don't remember the shape of Lithuania, unfortunately, so I have to
It's
use.
like Africa.
What does it look like?
A little bit like Africa.
It looks like Africa.
You can draw it.
I can try to draw Africa and then. That's like Africa, right? So you said Lithuania? So imagine this is Lithuania. You're watching the news, the weather of Lithuania, and you want to find out what is the temperature right now or in the future or whatever. That data, Lithuania is a continuous phenomena. There are no gaps in Lithuania like this. There's no big empty spaces. It's all filled in, so to speak. It's a continuous phenomena. However, if you want to know the temperature everywhere, you do have to use a thermometer. You cannot, the meteorologists in Lithuania do not measure the temperature at every single location in Lithuania. They just can't do that because it's too expensive. It's not practical. So what do? They measure the temperature here. They measure the temperature here. It's not really true, but the point is they measure the temperature in different spots. If they're lucky, the spots are evenly spaced in the longitude and latitudinal directions. So if I have a thermometer at these spots, I know the temperature at those spots, but I cannot put a thermometer everywhere. But now, if your hometown is in the middle, here, between these four spots, and you say, I want to know the temperature in my hometown, how can we derive the temperature in your hometown from the data, the discrete data samples that we have, the measured data? That's the idea, and that's what interpolation does. It derives the missing values, if you want to say that, or the values that are in the gaps between the data samples, derives them.
That makes a lot of sense. So, but are you going to need to know, because you have like terminology, you have these functions, you're going to need to know.
There's a lecture on kind of, that talks a lot about interpolation, and you are supposed to understand that.
Like nearest neighbor, linear, trilinear.
Yes, you want to know those, the differences between those. So nearest neighbor is just finding the nearest data sample and copying it. Saying, oh, the nearest one is here. I'm going to just use that. Linear means basically using two of the nearest ones. And then trilinear is extending linear into three-dimensional space. And there are more, but those are the only ones we mentioned in this class. And you can think of them, there's a term I used in the lecture, I guess nobody can remember, but there's a term that I used in the lecture to make it all simple. I think, does anybody happen to remember? I said, just think this.
Weighted average.
What?
Weighted average.
Yes! What's your name?
Oshan.
Oshan. Yes, it's a weighted average. That's really what it is. It's a weighted average. And then I started talking about, okay, what's an average? It's just the sum of numbers divided by the number of numbers. Then the weighted average is giving each one of those a different importance. So a different weight. Yeah, so it's a weighted average.
Notice that nearest neighbor interpolation and linear interpolation are really similar to aliasing and anti-aliasing. What is the fundamental difference?
So you can imagine, so if I use nearest neighbor interpolation, now watch this. If I can do this correctly, I'm going to draw a region that looks like this. If I was looking up the temperature for Lithuania, I was trying to draw a map of Lithuania with the temperature on it, look at what would happen. Using nearest neighbor interpolation, I would end up with a region like this that represents a constant temperature. Because every point inside this box has this single temperature as its nearest neighbor. And boom, there it is. It's forming a box. A staircase effect, which is also known as aliasing.
So they're sort of interchangeable, like.
So nearest neighbor interpolation and aliasing are very close. So nearest neighbor, say that 10 times fast. Nearest neighbor interpolation. Nearest neighbor. Oh, I won't do it. Nearest neighbor interpolation causes aliasing. Yes. Linear interpolation can also cause aliasing, but it's much harder to see. If you zoom in a million times, you can see it, but that's the idea. Good question. And I'm happy about this example. I never drew it like that before. Other questions? Comments? I think every single question has been answered and recorded. Every possible. You have the new problem is now just watching all the answers, right? Because that takes time. Did anybody notice the settings button in the YouTube videos? There's a little settings button. Anybody ever look at that? It's pretty cool. So you can watch the video back at different speeds, so if you're trying to go faster instead of at a higher speed. It's pretty cool. It works pretty well. It's interesting. I would like to know how they did that, but normally when you play a video back faster, all the voices go up like the chipmunks. But YouTube has done something with the audio.
You can speed something up and then pitch correct it down by...
That's what they've done, yeah. So the pitch does not, I don't sound like a chipmunk always. I think it doesn't work at all speeds though, right? It does start to
If you do a high enough speed, it just mutes it. Like, what's the point of listening to audio at 16 times speed?
Yeah. But it works for like 1.25 and 1.5 speed pretty well.
I have a question. So I have a question about shear wire factorization.
Yep.
Like this is alternative for the raycasting.
Yes, the shear warp factorization is raycasting accelerated. It's an algorithm that tries to speed up raycasting, the original raycasting. The original raycasting was slow, and so they thought of a way to speed it up. That's the idea.
I mean, like when is it useful and when it's not? Or is it always useful that they always use it? It's used.
For volume visualization, it's useful for fast volume visualization. The sort of drawback with the original shear warp algorithm was zooming in. So zooming in can cause aliasing artifacts, where the original raycasting wouldn't have as much aliasing artifacts as the shear warp algorithm. Because the shear warp algorithm relies on this one-to-one ratio between voxels and pixels. And as soon as you say there must be a one-to-one ratio of voxels to pixels, then you can have aliasing artifacts when you zoom in. right? Because the voxels get further and further apart the more you zoom in. Carlo?
To perform shear work, right, like you need to shift basically each like row.
Slice, yep, or
Yeah,
up.
each slice of voxels up like at a certain amount, so they're all shifted the same, right?
Yeah.
So how do you determine that amount? Do you shoot a rate first and see where it intercepts and then you use that, or is it arbitrary in some way?
You shift based on the viewpoint, based on the view vector.
So you first look at the angle at which the viewpoint goes to the object, and then you make it 90 degrees.
Exactly, exactly. You shift based on the angle that the view vector makes with the volume.
So in a way, it's like at first you do something like a ray trace. So you put a ray to the object, and then you see what the incidence is.
Something like that, yes, yes. So I'll try to draw this. So this is the perfect scenario. That is supposed to be an eyeball, looking at the view, the volume data. And in this case, there's no rotation, and we're looking straight on. So there's no shear necessary at all. It's very unusual to be in that configuration. But as soon as we rotate just a little bit, so now we're looking at the view this way, and we have some angle of rotation around the central axis. Maybe, well, I'm not doing a very good job here, but it's going to be theta plus 90 degrees, right? Because this is 90 degrees here. So theta's going to be that other part of the angle, so to speak. This is going to be theta. I should draw it like this. Now, in order to recreate this one-to-one ratio, we then have to shear the data. Now, the amount of shear depends on theta. So the bigger theta is, so there's going to be, it's going to look. So actually, the way to draw this is then to rotate the eye like this. So it's looking, I'm going to try to draw this the same. Right, so now we're looking the same. And again, this is a right angle. The amount that we have to shear this is going to depend on theta. It's going to be a function of theta. And I want to make sure I don't shear it in the wrong direction. So you can think of it, the way you think of it is you extend the ray here. Now look, the ray is no longer hitting the center. That's the center. The ray is no longer hitting the center of that slices. It's hitting over to the left. So that means you have to shear a little bit to the right. That's not the world's best drawing, and then you have to shear a little bit to the right. And this amount is going to be something like d times theta, a certain distance d times theta.
And theta is established on the angle at which you hit the cube that forms the object space, not the object itself, because that would be a bit hard. Right?
Yeah. So it's all about this theta. And if that thing is totally, if it's very big, then it's going to look more like this, bigger shear, so to speak. And you might think, well, it's going to miss some of the slices. Yeah, it's going to miss some of the slices. If you tilt this thing a lot, it's, the ray is going to go straight out the side, so to speak. It's going to miss some of the layers. I highly recommend that one of the previous student questions on this, the shear warp algorithm of fast and convenient summary.
Yeah, I've watched that.
I think there are 2 videos. One's like run length encoding for the shear warp algorithm. But nobody asked that question yet. Nobody asked that question as far as I can remember. And I conveniently left it out. It's kind of not really there on any of the slides. I don't think there's really any, and I don't think there's any mention of that angle really in the video either. I don't think. Imagine I wasn't here to answer that question. What would you do? Yes, you would, exactly. Well done. You would look at the paper. I don't think the paper talks much about it, that much about it either. I can't remember actually. Other questions?
No, I have one about.
If we were asked the shear warp in the exam, would we be okay to answer it with just illustrated diagrams and like just discuss point of it, or do we need to more go into like the step by step, the shear, project, warp, and like discuss every step in detail?
It depends on the question.
Like, would you be okay with it being more?
If the
big
question,
diagrams?
if the question was, tell me, give me a summary of the shear warp algorithm, then I would encourage this level of detail. If the question was like, tell me specifically about the run length encoding of the shear warp algorithm, then I would expect this something like this level of detail. You can see that I think there's a pretty consistent level of detail in all of these videos, and they're all very much relying on drawings, annotated drawings. Yeah. I think that a lot of people try to do a lot of smoke and mirrors hand waving with words, with natural language text. And it's harder to do smoke and mirrors hand waving with diagrams and drawings.
That's very true. And you have a lot of colors.
Question?
So, in the case of run length encoding, do you have to specifically do it with shear warp algorithm? Can you not just apply it to regular state?
Yes, definitely. So the run length encoding algorithm applies to all data in the world. And I'm not 100% sure, but I thought that it comes from the world of networks. How do you send as much data over a network in the shortest amount of time possible? I thought that's where it originates. I haven't Googled that.
It's a form of compression, to a degree.
Yes, it's a form of compression. Yeah. There's a small chance that it originated in image processing. I'm not sure, but I thought, at least when I was a student, that's where I first learned it, was in networking. Yeah. Any other questions?
One of the questions was about hierarchical data, the 3 types that
Yeah.
visualization you can do is compare them. So there will be tree map, trees, and Venn diagrams, right?
Yeah.
Because we're talking about information visualization, the strength and weaknesses are not necessarily technical. They might just be the fact that a Venn diagram is more readable for the average user or something like that.
Correct. Cognition, interpretation. Yes, so the tree diagram is going to be very easy in terms of cognition and interpretation. That's going to be the advantage of a tree diagram. Everybody understands it immediately. And a disadvantage of the tree map will be cognition and interpretation. So people see a tree map and they don't understand it. Venn diagrams, people see a Venn diagram and they think they understand it. So that could be the most dangerous, actually. When you think you understand something that you don't, it's more dangerous than if you know you don't understand something.
See, it's both the mirrors work.
Yeah. What about that tricky? Isn't there a tricky one? Like, how would you represent multivariate data in a hierarchical visual design? Isn't that in there or something like that? That's a tricky one, isn't it? Anybody? By the way, there are more than 3 hierarchical visual designs. Those are just 3 that we happen to talk about. But if you Google hierarchical visualization, you find lots of more. You look at the book chapters. Even a file system is a hierarchical visual design, right? Searching for your files in a file system. Right? That's what a GUI is, kind of. But how could you modify a tree map? Like, could you modify a tree map to handle multivariate data? Anybody think about that one?
Wouldn't you just use different markers or encodings, like color? Or
Yes, you can use color.
Or
Instead
the
of mapping
size.
color to size, you map it to something else.
Did
Yep.
you do that with the car visualization in the tree map? The color was mapped to price.
Yes, exactly. Yep. I think we mentioned something else in the lecture.
Multiple views.
Multiple views, yes, that's a valid answer. Yes, wasn't thinking about that, but definitely. Multiple views is a valid answer. Like you click on a square in a tree map and another window pops up with a pie chart or something.
In the case of trees, would annotation work? So annotating the edges and nodes.
Annotation might work. It would be very difficult, but it might work. You could use textures. You could texture map the rectangles and encode something there. You could use opacity. You could vary the opacity of the triangles and map. Some people would argue strongly against that, but it's a valid answer. It doesn't say how could you do this in the most successful way possible. It just says how could it be possible.
So in a file system example, when you draw a tree map, for instance, so each square will be mapped to size. But say you want to have a color scale for a file number in each one, then you could do that, right?
Yes.
Color can away from multivariate data.
Color can be mapped to anything. And yeah, so you always have at your fingertips color, texture, opacity. You have things like shape as well. You might try to vary the shape of those rectangles in some way to encode something. That's an answer. That's a valid answer. You might try to do something with the edges, maybe, or you might even put a glyph in there. That's like a super duper answer. Like add a glyph inside the rectangles of the tree map. That's perfectly valid. It's not very good when the rectangles get small, but how could you handle that? How could you design a tree map that can handle 10 million rectangles? Anybody the answer to that?
Context and focus. Context and focus.
Focus and context, yes, yes. And in fact, we don't talk about it much, and I don't even know if I mentioned it, but in that application, you can click on a node and then expand it so it is the root node. It becomes the root node in the tree map. So you can traverse the hierarchy up and down. And we do have one explicit example of that in the lecture. It's the word tree, where somebody's clicking on the node in a word tree and it's opening up and collapsing again. So interaction, by the way, that's a general theme. How do you take an existing visual design and make it accommodate millions or billions of data values? A very, very common theme is to add some sort of interaction to address that problem. And one of the examples we looked at was with the graphs. We had this complicated graph with lots and lots of crossing edges. And the way to resolve that was to interact with the graph, click on the node you were interested in, and then watch the edges that are connected to that node be rendered in focus. So interaction is very, very, very often used to resolve this conflict between design, the limitations of a design, and the size of data sets. Brushing is another example, especially in parallel coordinates, like selecting a subset along an axis and focusing on that subset when there are too many polylines everywhere.
Most interactions are based on filtration, one way or another, aren't they?
Yeah. Selection or filtration. Yeah. Good stuff. The questions are a little bit more specialized this year because so many of the questions have already been answered, I think. So they can only get, and unless you repeat a question, you can only ask like more specialized questions than what's been previously asked. So everybody's going to do amazing on the exam, I guess. You usually have questions. You afraid to ask them in front of the class? You have a stack of 1,000,000 questions sitting there. I can't wait to ask all these questions after the class. Everybody wants to know what he's going to ask. Okay, I guess we'll stop then. Please don't send me questions on Sunday or something. Like, it's not gonna. I don't have any plans to check my email Sunday.
Monday morning.
What time? What time? It's at 1:45?
The exams at 9:45.
9:45.
So the emails are around 9:45. Is that all right? I was sure there's someone.
Oh, when's the exam?
I heard it was 21st.
Yeah.
Good thing that you came to this lecture.
Do you recommend that we bring
Maybe a different exam.
Yeah.
So, good. So, and you list all the lump fixed separate chicks. Yeah, then you end up shouting chicks. It's got to have the chicken direction. 2D, how would you present it? If it's just XY.
In that particular those groups were meant to be depicting in surfaces, so when you carefully slide, it's actually the close confined to a surface. So if there can be yeah, 2.5D. There is a Z component theoretically.
Doing dimensions without having like positions and directions. Because that seems to be the two.
That's right. So you could add things like temperature, and you can encode temperature with color.
So it's mostly color and shape. Usually
that's right. Like you could change the base of the lift, like make it bigger or smaller, compression picture out.
So when we
You could extend the length of it, make it correct. Yeah, no problem. This is the fuzziest, I think they're the fuzziest topic. They're the most inexact science of all topics. Step 1, step 2, step 3, algorithm. I think you'll be fine.
Hi Bob. I usually print out all the lecture notes at the very beginning of the semester, and I'm now doing the revision for that visualization. And I found you have a specific slides on splitting and filtering, but I found you see it's deleted, or like what was it? Does it mean it's not going to be included?
Splitting is no longer included.
Oh.
Yes.
And the angular histogram.
Yep.
I remember there is like an additional slice, and you include like an algorithms about the attributes curve and the angular histogram, like small formulas. Are you going to ask us to understand that algorithm, or we are just going to write, okay, what this algorithm do, what is the advantage and what is the disadvantage? Just briefly describe it, or we have to calculate something based on.
Sometimes previous exams do ask you to calculate things.
Yes.
Yeah. So it is possible. Yeah.
Alright, so what you
For
mean
the
is-
angular histograms, typically, that would be how can you modify parallel coordinates to handle very large data sets? And then the angular histograms would be a good answer for that question. That's the idea behind angular histograms.
So it's not going to be too much focus on the details, how the algorithms works, how.
Well, the angular histograms are really, really easy, right? You know what a histogram is.
Yeah.
You know how to compute a histogram.
Yeah.
And then you just add the average angle of the line intersections. So you can compute the height based on the standard histogram, how often a polyline intersects an axis, and then you just take the average angle that the polylines hit. And then you have your angular histogram. So that's what it is. It's just those two.
Because it is on, like, I consider it is like an additional PowerPoint, and I have no idea, are you going to be asked something inside that, or like.
Typically, it would be something like in that last part of the questions that always is asking for limitations and reasons why things are the way they are. You know, like how do you extend this so that it handles very large data sets or something. And that's always a limitation. Limitations and data set sizes, those two topics come together very closely.